Okay, I have my calculator now, so we should be okay. Number 6. Let me just redo it. We are supposed to find the sum of the first 6 terms of this geometric sequence that they gave us. And so they gave us some terms that were side by side, and they gave us a sub 1. So that is so helpful. A sub 1 is 5, because it's the first guy. Take 2 terms. 15 divided by 5 gives me 3, or 45 divided by 15 gives me 3. So R is 3. So to find S sub 6, I'm going to use this. A sub 1, 5, times 1 minus R, which is 3 raised to the nth power, the 6th power, all divided by 1 minus R, which is 3. So this is 5 times 1 minus 3 to the 6th, which is 729, divided by 1 minus 3, which is negative 2. This is 5 times negative 728 divided by negative 2. And that turns out to be 1,820. So that is number 6. Okay. Number 7 goes like this. Find the sum. They gave us this summation symbol, and we know that means add up these numbers. And so they could give it to you like this, or they could also say find S sub 5, which is the sum of the first 5 terms. And this one says to do it by hand, and so that's what we have been doing, no big deal. 2 to the k, 2 to the 1, 2 when k is 2, when k is 3, when k is 4, when k is 5. Okay, so 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32. We're going to add up these numbers. Let's see, 32 plus 8 is 40. You don't have to add this way, it's just how I like to do it. 16 plus 4 is 20. This is 62. All right, that's our answer. Now, number 8 says find the sum using your calculator. Now, never going to make you use your calculator. Well, in matrices, you kind of have to. I guess if you didn't want to, but you might not have that many hours to do matrices by hand. But if you wanted to add this by hand, you certainly could. But it's easier with a calculator. And if I say, hey, you're allowed to use your calculator, you don't have to show me any work, then I would do it. So I have the TI. What I'm going to do is hit... I'm going to clear my screen. Okay, I'm going to sum the first 5 terms. So the first 5 terms, not that big a deal, but if it was something like 18 terms or something crazy like that, you would want to use your calculator probably. So hit math, and then go down to the 0, and that's your summation, and this is what it appears on my TI. And if you have a different one, you need to consult the tutoring center, the math center, building 4 people. Even though they're not physically in building 4, they're still helping people, and they can help you out with that. So now I have all the places. I'm going to use my variable x to enter that. I'm going to say x, which is your x, tau, theta, n. It's next to your green alpha button. That's the x that I'm going to use. I'm going to say x is from 1 and then up to, oops, let me go again, math. 0, okay, x, and it toggles all over automatically. I'm going to enter 1, and then I'm going to use my up arrow to get to the top number and put in 5, and then I'm going to enter this carefully. I'm going to say 216, and then I'm going to add a new parentheses to put the 1/3 to the power. 1 divided by 3, close parentheses, raised to the power x. And all of that is in my big summation. So this, you can see it, is how I entered it, okay? And then I just hit enter, and it gives me the answer. And so if I ask for decimal, you can give me decimal, or if I don't ask for something special, this is 107.56. But if I say give it to me in fraction, if you guys don't know this button, it's a great one. Hit math, and then hit enter, and it will turn whatever your result is into fractions, and that's going to be important when we hit matrices. So 968 over 9 If I said, what's the fraction sum, you'd need that. If not, you could do that. Okay, number 9 is going to be real straightforward. We're going to add up the first 4 terms. S sub 4 is how they could say it. You could use a formula, but I think this is going to be real simple. Negative 2 to the I is 1, plus negative 2 squared, plus negative 2 to the third, plus negative 2 to the fourth. Negative 2 to the first power is just negative 2. This is positive 4, this is negative 8, this is positive 16. So this is 8, and this is 2, and so my answer, that sums to 10. That's number 9. Number 10, we already answered earlier. What are the conditions under which you could add an infinite amount of terms? When the common ratio for a geometric sequence is, the absolute value of the common ratio is less than 1. So, number 11, they say add up this series, all of the terms, the infinite series. And so, first they say determine if it converges or diverges. Okay, if you can add it up, if the conditions are met that the common ratio is less, the absolute value of the common ratio is less than 1, then that will converge. Otherwise, you cannot find a sum and it's divergent. So, first, we should determine what the value of R is. You can take one further down the road, 1/3, divided by 1, and we get 1/3. So this is what R is. Well, the absolute value of 1/3 is 1/3, and that's less than 1. So this guy is going to converge. Okay, in a minute, I'm going to come back and find the sum and find what it converges to. Right here, let's figure out what this guy is. Pull out 2 terms. I'm going to take this one. Take the one further down the road, 1/5, and divide it by the one in front of it. Negative 1/25. This is a keep, change, flip, or a division of fractions. 1/5 divided by or multiplied by the reciprocal of this is going to be negative 5. The common ratio is negative 5. Well, the absolute value of negative 5 is 5. This is not less than 1. So this guy diverges. Okay, let's see. What is going on here? This is like a little complicated, it looks like. But if you lay out, you have 9 times this. 9 times 9/10 to the 0 power is what this starts with, plus 9 times 9/10 to the first power, plus 9 times 9/10 to the second power. What are we multiplying each term by each time? It's 9/10. So sometimes it helps me to write it out, and that helps me just see exactly what R is. So R is 9/10, and that absolute value of that is 9/10, which is less than 1. This guy's going to converge. Okay, this guy converges, this guy converges, this guy diverges. D, I fit him in right here. Okay, so again, I'm going to write some things out to see what I think that looks like. The first term, when K is 0, will be 0.3 to the 0. Or if you want to write 0.3 as 3/10, that's what 0.3 is. That is fine too. Then the next one's going to be 3/10 to the 1, 3/10 to the 2. I think it's pretty obvious that R is 3/10. The absolute value of 3/10 is 3/10, and that's less than 1. So this guy also converges. All right, so the only thing left for us to do is to find out what the sum of A, C, and D are. So let me just make some room on my board. We already did this problem. We don't need this stuff in our way. We need this formula, though, that's for sure. We don't need B. Let me get rid of him. I think that's enough room. So now let's go ahead and find the sum. A. What is the sum of this geometric sequence? Okay. This is the formula for the infinite sum. It's equal to A sub 1 over 1 minus R. We got to know what A sub 1 is. A sub 1 is 1. R is 1/3. Okay, ready? S sub infinity for A is equal to A sub 1, 1, over 1 minus R, 1/3. Well, this is 1. 1 minus 1/3 is 2/3. This is 1 divided by 2/3, or 3/2. This is what the infinite sum is. It converges to 3/2. C, let's figure out this guy. What does he converge to? The sum infinity is equal to a sub 1. What is a sub 1? Well, you got to kind of figure it out. Let I be 1. 1 minus 1 is 0. I already wrote this down, so I'm going to use this work I did. 9/10 to the 0 is really just a 1. So 9 times 1 is 9. 9 is the first term. So a sub 1 is 9 divided by 1 minus r. R is 9/10. So this is 9 over 1 minus 9/10 is 1 over 10. 9 over 1 divided by 1 over 10 is a keep, change, flip. So this is going to be 90 is what this guy sums to. This B converges to 90. All right. D right here. D is right here, this 3/10 stuff. Okay. R is 3/10. What is a sub 1? Oh, well, a sub 1 is the first term, and the first term is formed by taking 0.3 and raising it to the 0 power. Again, this is going to be 1. This is going to be a 1. So S sub infinity for the last one is going to be 1 over 1 minus 3 over 10. 1 is, you can think of it as a 10 over 10. 10 minus 3, this is going to be 7 over 10. 10 over 7 is what D converges to, 10 over 7. So that is geometric sequences and series.